Where BSc Science আছে? হ্যাঁ তো বাড়ি এখন যাবি না আমি চলে যাব না start. So step by, I'll say you write step by step. These analyses, again I'm telling based on secondary data. Again repeat, these analyses based on secondary data. Okay. And basically, this is the stock market data. Stock market data. Here, stock market data. So, and this is the paper actually published in 2011. It's an old paper. So I am telling you, after completion of this paper, there is a lot of scope in 2022 also, to go for some futures. There are so many opportunities because for this paper there are some limitations. Some limitations, definitely I will tell you also the limitation of this. So initially when you start this paper, so we consider total 10 variables because it is based on capital market paper. So we collected census data and 9 macroeconomic parameters. Macroeconomic parameters. So, since we are not from the finance background, so better we consider the 10 variables. And all 10 variables are scale variables. And out of 10, 1 is dependent and 9 are independent. So first of all, you have to think about all independent variables are important or not. Is it okay? Important or not? So is there any high correlation with the dependent variable and independent variable? So initially I will show you the analysis using only correlation matrix. And then from that you get the idea how the variables are important for determining the dependent. This is the first. So definitely there are some limitations. So then we will start the regression analysis. And again regression analysis, if we check that, there will face some limitations. And for this problem, regression also will fail. So I will show you that out of 9 variables, all variables are not important to predict the dependent. So naturally, automatically, the question will be asked. So why initially you consider the 9 variables? Because you collected the data set from your domain knowledge. So that's why we go to the other analysis that is called principal formula. Question is why our main objective is how to explain more the dependent. This is the main objective. So this is basically cyclic part. Cyclic part means started from supervised learning. Again, if we started from supervised learning, while we can consider one dependent and more than one independent and fail, then we take the help of unsupervised learning because factor analysis PCA is the unsupervised learning. And again we come to the supervised. So it's a totally cyclic process. Again repeat, this is very interesting. You start from supervised learning, you fail, then you go to the unsupervised learning, we take the help of factor analysis. Ultimately again we reach to the supervised learning. Question is why? Because our main objective is how to improve the value of our score. This is the main objective. So we will show everything. Using correlation, we check the R square. Using regression, we check the R square. Not only that, when you start the correlation, we can easily check that how many out of 9 variables, how many variables are important. Easily check. I will show you. Similarly, when you start regression, easily I can check that out of 9 variables, how many variables are important. And what is the value of R. So our objective is to increase the R square. Not only increase the R square, it is a trade-off in the research. What is the trade-off in the research? Not only increase the R square, take the maximum variables considered from the domain. Say initially I collected 9 variables, but due to some statistical analysis, I removed 7 variables. That is not the research. Because statistical analysis, is a tool. So always you try to mapping between domain knowledge and your statistics. So with this is not coming down. So what is the step 1? You can write. Step 1 is correlation matrix. And from correlation matrix, we get in the output of Jamovi, we get 10 by 10 matrix. Now why 10 by 10? Because there is one dependent and 9 independent variables. So that's why we get a 10 by 10 matrix. Is it okay? And in correlation matrix, we consider only the first row. Question is why? Because first row contains a dependent variable. We consider the first row. Question is why first row is 1. This is the correlation value. This is the correlation value. This is x1. So that is the correlation between y and x1. This is the correlation between y and x2. So naturally, when you use software, no need to check manually. So we check, no need to check all the values. We check only the p-value. We check only the p-value. Is it okay? We check only the p-value. Here, question is why? If the p-value is more than 0.05 for some variable, that variable will be discarded from the analysis. Because p-value more than 0.05 means we could not reject H0. H0 will be accepted, the level. So H0 accepted means we are no correlation. So if p-value greater than 0.05, that implies no correlation. So no correlation means we can easily reject. That's just simple. Is it okay or not? So just you go to the regression. So now you just, is it okay? Regression, you select correlation matrix. You select correlation matrix. Okay? And you select all the variables in the right hand side. Is it okay or not? If you get, then I will start. Clear? 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 Now, so just you check Here sales tax is the dependent variable. That is the first column. And these are all values. All values. So only check the p value. Now what is the first p value? You tell. Why? You discard. Clear? Because it is point greater than 0.05. Simply you discard. That is no relationship with the sales tax. FPR greater than 0.05, discard. Is it clear or not? Similarly, CMR, discard. Now that is CRR. Will take because it is less than 0.0. Okay. So which is less than 0.05, you give the right part. Right. Similarly, oil less than 0.05. Similarly, dollar. Clear. And FDI. Foreign. Forex. Is it okay? So just you think using correlation matrix on the basis of p value, we are able to discard some unimportant variables. Is it okay or not? So initially we start with how many variables? 9 independent. 9 independent. How many variables are left? Only 4. 1, 4. Clear? Any question? Sure? Can I go to the next step? Yes or no? Yes, sir. Yes. So now, Shayon, from this analysis, you discard gold. Better you move from right to left. Because gold is cancelled. Then you move from FPI. Then you move from CMR. Slowly. CMR. Is it okay? Then FDI. Then foreign. Then foreign. Foreign or here. Is it okay? So now this is our modified correlation matrix. This is called modified correlation matrix. I hope it is clear to all of you. So just you check in the modified correlation matrix, all p values are less than 0.05. Is it okay or not? So out of 9 variables, we consider only 4 variables. Now, we need a model. We need a model. So, what is our model? Initially, y is a function of 9 variables. Is it okay? Now, after using correlation matrix, y is a function of any 4. Is it okay or not? Tell me. Where x1 denotes CRR, x2 denotes oil, x3 denotes dollar, and x4 denotes what is that? Forex. So these are the 4 variables. Any question? Now, I need a model. So first of all, anyone can ask the question, what is the meaning of model? So model means you have to find what is the value of R square. That is means how much you can explain the model by the predicted variables. How much, you can repeat, how much you can explain the model by the predicted variables. Because there are 4 predicted variables. Okay, so now we go to regression again. So, in the regression, under regression there is called linear regression. Under regression there is a select. Clear? And when you select these, automatically some menu is open. And some menu, one is the dependent variable menu, and one is the covariance, and one is the factor. So when you solve, I'm telling you, when you solve any primary data work or ordinal data work, so in this problem, all are scale variables. All are scale variables. So you consider the variables under covariance, not under factors. So factors will be implemented when you take the categorical variable. Factors will be implemented when you take the categorical variable. Okay. So now we consider sensex as a dependent variable. Is it okay? Sensex as a dependent variable. And now we have 1 minute. Oh. So for correlation matrix, which 4 variables we get? CRR. We select CRR. CRR. We select oil, dollar, and I hope it is clear. Is it okay or not? So now the problem starts. So when you consider the 4 variables, then R square is 67%. 67%. Is it okay? That is 67.7% explained. And definitely nearly 33% unexplained. Okay. Now I will come to the very important part of p-value. Very important part of the p-value. Hello. Okay. P-value. For the first CRR, p-value is greater than 0.05. Is it clear? So that means on the basis of p-value, we can easily discard CRR because p-value is more than 0.05. So CRR is discarded. Clear? So now you go to the model coefficients. Just check model coefficient as come. Model coefficient. And in model coefficient, you get the last column, that is the p-value. Okay? Last value p-value. Now what is our conclusion? If the p-value is more than 0.05, then we reject the variable. Simple. That variable is not important for the dependent. No significant effect. No significant impact on dependent variable. So on the basis of this, oil we can discard because 0.364 is greater than 0.05. Is it okay? But dollar less than so dollar is less than 0.5. So we'll take this. Forex will take this. But CRR is greater than. So how many variables we consider for the next step? Only 2. So one is dollar. One is dollar, another is the forex. So you remove CRR. square হয়?
Yes, sir.
Remove. So just you check, when you remove this, now what is your R square? 63. Very good. R square. That is equal to 63. Is it okay? And okay. So definitely 37% nearly unexplained. And if we write the model, that is sense X is a function of only dollar and only two variables. Initially we started the 9 variables. Now come to the 2 variables. Out of 7 variables are reduced. So really this is a problem. So question is in the research that how we can overcome this problem. How we can overcome this problem. This is a real life case. Second person হয়েছিল with the 4 variables. কমে গেল তাই জন্য তো this is the demerit. আমরা তো করব না। আমি স্টেপ বাই স্টেপ আবার লিমিটেশন গুলো স্টাডি করছি। করতে করতে তারপরে পেপারটা লিখি। So now what then we go to the again the initial step. Initial variable. চলে যা initial regression. Regression. This is very, very important stage, I am telling you. We apply okay, when you start, you take sense X as a dependent variable, you start. Sense X as a dependent variable. And all 9 variables under independent. Huh? Linear
regression ই করব তো ये সবকটা ভেরিয়েবল নেব ডিপেন্ডেন্ট এ গৌতমদা সবকটা ভেরিয়েবল এবার ডিপেন্ডেন্ট নেব
You go to the regression, you take sense X as a dependent. This part is very important, I am telling you. And all 9 variables are under covariance. That's all. Is it okay? All 9. Clear? Sure? Huh? Now you tell these are the p values.
বি গুলো তো একদম গড়বড় হয়ে গেল
Out of p values, these p values, which is the maximum p value? Can you tell? CRR. Maximum p value CRR. So which is the maximum p value? First we remove that variable. So you remove CRR. CRR.
ফরেনটা আছে আর স্কয়ার ইমপ্রুভ করে গেছে
Clear? Hello. Which is the maximum?
সিআরআর ম্যাক্সিমাম
So after removing, now how many variables are left? 8. Now out of 8, which is the maximum p? You discard 4.
ফরেনটা সবথেকে বেশি না মানে এবার ব্যাকওয়ার্ড যাচ্ছে
We are using the backward integration, right?
ব্যাকওয়ার্ড যাচ্ছে
Now which is the maximum? You will discard it. FPI. Now
FDI
is the maximum. CMR. Discuss here.
এফডিআই কে বার করার পর সিএমআর, তাই তো?
Now which is the maximum?
FDI.
Discard it.
Forex.
Now which is the maximum? 1 minute. Here forex.
FDI.
And now which is the maximum?
Oil.
Oil. Discard oil. Now all values are less than 0.05. So just in R square is 0.7.
অনেক ইমপ্রুভ করে গেল।
But there are only two variables. So definitely we can say the backward integration method is good enough. Backward integration is a good enough method. Is it okay or not? But the problem is that out of 9 variables, only 2 variables are. So automatically the question will be coming. Initially we start with why maximum without any domain knowledge. Because we started our research with the domain knowledge. So how we can improve maximum variables? Not only that, to improve the R square. Is it okay? We improve, this is the trade-off. We have to improve R square. Also we have to consider maximum. Okay or not? So question is why we consider go to the next method. This is the real question. So again we go to the initial stage. Initial stage. Regression. Linear regression. We select dependent census. And all 9 independent variables. Because we have to show in the paper, try to understand, we have to show in the paper that correlation failed because R square is less. Correlation failed due to all variables are not constant. Minimum variance are constant. Regression failed due to R square less, all variables are constant. Backward regression failed, R square increased, still all variables are not constant. So now we need to check, is there any other method? Is it okay or not? To increase the R square and not only that, to consider the maximum. This is the real problem. So what is to do that? We select assumption check. So in the assumption check, there is a concept called collinearity statistics. Already I told you BI. Back end already I explained. Collinearity statistics. You select. Collinearity statistics. Huh? R square actually, that's why I'm showing you. Because our objective is to how to get the maximum. That's what I'm showing. So these are the BI values. Is it okay? So just to check that all BI values are more than plus 2. All BI values are more than plus 2. So when all BI values more than plus 2, simple regression failed. Is it okay or not? And huge multi-collinearity occurs. So we welcome PCA pattern. I hope it is clear. Clear? now I will explain the concept of PCA and factor analysis. And if I take time, and if you are naturally support me, and then definitely I will show you somewhat of. So, now, so to understand PCA, I hope you have heard the term principal component. It's a very well-known feature in data science. So I am requesting to all, after my today's class, you try to consult with some book. A very famous book on PCA. That is the Advanced Multivariate Analysis by Johnson Witcher. So already I have given the soft copy to Professor Krishna.
প্রথমে ওটা ওই সেকেন্ড পার্টটাকে পেলে একসাথে আমি কম্পাইল করে সবাই
I have given the soft copy. I have given the two soft copy of books, one for PCA and one for Atlas. Already I have given the two books. And actually, I am telling you frankly, I am basically the layman about this in 2008. And from 2008 I started to learn the concept of factor analysis. And because when I started to learn, so then I started this book. And this book, if you read 5 times minimum, so it's a story. It's a very uniqueness. If you read this book 5 times, if you read the book 1 time, so you throw it. But if you read the same book 5 times, it's simply story and task. So that's why I'm telling a very interesting story of PC. This book starts with 3 variables. 3 variables to understand. Here we are considering 9 variables. Book started with the 3 variables. This says x1 is 1 variable, x2 is 1 variable, and x3 is 1 variable. Is it okay? And x1 is the the problem is when we are considering regression, that is the dependent variable and that is the independent. Your left hand side is the dependent, which is known. Right hand side is known. Is it okay? This is very interesting. In case of regression, your left hand value is known. Your right hand value is known. All xi you know. So easily you can use the least square. Is it okay or no? But the problem starts, your left hand member is not known. When there are 3 variables, when there are 3 variables, you have to consider these 3 variables all are independent. Initial thing. So that means F1 is the linear combination of all 3. Linear combination of all 3. F2 is the linear combination of all 3. And this is also linear combination of all 3. Is it okay? So this is the 3 equation. The problem is left hand side are not known. We don't know what is F1. We don't know what is F2. We don't know what is F3. we know only the values of x1 column, we know the values of x2 column, and we know the values of x3. That's all. Not only that, we don't know these coefficients. So if there is no mathematics, no statistics to solve this problem, so we take the help of Cayley-Hamilton technique. We take the help of Cayley-Hamilton technique, that is called the characteristic use. So, but when I am telling you, what's the difference between mathematics and statistics? Someone can ask me, what's the basic difference between mathematics and statistics? The difference in mathematics and statistics is mathematics gives the exact result. Statistics gives the approximate. Is it okay? So mathematics, if we take the 10 sample, so on the basis of 10 sample, easily you can calculate mean and standard. That is mathematics. But in statistics, on the basis of 10 sample, we can test it for the population. What will come? What will predict? So that is called statistics. So definitely in the statistics, there is a huge chance of error. But in case of mathematics, no question. Because this is the determinant. So this is the real. So this is the why PCA is so popular. I am telling you, PCA is the combination of mathematics as well as statistics. So some data scientists, they are using PCA on the basis of mathematical method. But we are the statistics students. So we will use the PCA with mathematics as well as statistics. So today I will try my level best. Know what is the impact of mathematics in PCA and what is the impact of statistics. Then you can understand the total philosophy of this. So what is that? That's very interesting. Say, here the x1, x2, x3 are values are given. Here, in mathematics there is a very interesting term that is a matrix. It is a square matrix. And the matrix may be the symmetry. Matrix may be the asymmetry. The problem is we are taking the advantage in statistics. We just put the condition, try to understand, we put the condition that the matrix must be the symmetric because correlation matrix is the symmetric. We take the help of statistics. Covariance matrix is the symmetric. That is the advantage we are taking. Question is why? Because there is a property of Cayley-Hamilton that if the matrix is a symmetry, so naturally we get some roots. That is called eigenroots, characteristic roots. All are real and positive. That is the advantage. But if the matrix is not symmetric, real and positive, that part I am not discussing. So what if you take that, we form either covariance matrix or correlation matrix. But since you solve same for the last few days, so obviously same basically based on covariance matrix. So Johnson Eaton started the concept of PCA with covariance matrix. But when I solve the today's problem, then I will take the help of correlation matrix because it is easy to understand. Now, what is the covariance matrix? So, covariance matrix is that we get this 1 minus 2, 0, minus 2, 5, 0. I have copied directly from Johnson, 0, 0. This is the, since there are 3 variables, a 3 by 3 covariance matrix. And that is symmetry. Clear? And this is the diagonals. Now, in case of mathematics, there is a term that is called polynomial. There is a term called polynomial. So, naturally, what is the meaning of polynomial? Suppose if there are 2 variables, it can take 100,000 lakh cases. So we can form a second degree polynomial. If there are three variables, we can construct a third degree polynomial. So this is the uniqueness. If there are 20 variables, we can construct a 20th degree polynomial. Now how it is possible? With the help of Gaussian. So how we can form the polynomial? Suppose this is denoted by A. So we can take the help of determinant A minus lambda. So that is equal to 1 minus lambda minus 2 0 minus 2 5 minus lambda 0 0 0.
স্যার একটু মাইকটা নিয়ে নেবেন
ও মাইকটা নেই না সরি
স্যার মানে
মাঝে মাঝে কথাগুলো বেরিয়ে যাচ্ছে
হ্যাঁ মানে লাস্ট সাইড রিপিট
আমি রিপিট করব হ্যালো
হ্যাঁ
so now up to this okay 3 by 3 covariance matrix. So from the covariance matrix we want to find what is the polynomial, because since there is a 3 by 3, so we can construct a third degree polynomial. How we can construct? Simply you take the principal component, diagonal element. Question is, you can ask me the question, very interesting question of mathematics. So why we put minus lambda in the diagonal? This is a real question. Why Hamilton put minus lambda in the diagonal? So Hamilton put diagonal minus lambda in the off-diagonal position also. Why you do? That's a very interesting question. So definitely, because we know the value of the determinant starting from the principal. So this is the 3 by 3 matrix. This is the 2 by 2 matrix. This is the single matrix. So when you consider 3 by 3 matrix, you have to start from this diagram. So naturally, if we take this value of the determinant, we get a third degree polynomial. And for the third degree polynomial, we get 3 roots, 3 values. I am giving a simple example. Say x square minus 5x plus 6 is equal to 0. So obviously, how many roots? 2 roots. We know, if it is the third degree, 3 roots. And the advantage is, all roots are real and distinct and positive. This is the advantage. Okay. Here we solving the roots, we get one value is 5.83. Another value is 2.00. Another value is 0.17. We get this. If we solve, we get this value. Okay. Very interesting. And how we check that our answer is correct? Simply, you are taking the sum of the diagonal, sum of the roots. So that is called 8.00. In the mathematics, it is called trace. No, trace. So that is sum of the diagonal, that is 8. Sum of the eigenvalues equal to 8. It is the check. Is it okay or not? Now next part is, how many eigenvalues are more than 1? Tell me. How many eigenvalues? 5.83, 2.00, 0.17. So how many eigenvalues are more than 1? 2. So automatically, in mathematics, we are saying that if the eigenvalues are more than 1, that determines the number of roots. But from the statistics point of view, because I am a student of statistics also, so from the statistical point, I definitely will ask the question, why? Why we consider only lambda greater than 1? My question is clear or not? Why not consider lambda less than 1? Everywhere, written, if lambda greater than 1, how many lambda greater than 1, that indicates number of roots. My question is, as a student of statistics, that is why it is less than 1. Why not consider less than 1? Anyone can help me? Is it okay or not? My concept is clear. No, when lambda is greater than 1, suppose out of 3 lambda, how many lambda are greater than 1? 2. That means 2 groups. 2 groups. We have to consider 2 groups. Suppose you have taken 7 variables. That means we can construct a 7-degree polynomial. And you get 7 eigenvalues. And out of 7 eigenvalues, if you check the 3 eigenvalues are more than 1, that means 3 groups construct. That is my question, why it is not less than 1? My question is clear. The answer is very simple. Answer is, what is my objective? Objective is, already in the morning class I discussed, there are 3 groups. One is the within group, this is called between. Within group, another is the between group. I've already discussed. So I need some separation between the groups. Separation between the groups. Is it okay? So that is called between sum of square. Between sum of square. And this is called within sum of square. Between sum of square, and that is another is called within sum of square. And this between sum of square by within sum of square, it is the philosophy of that statistics. Now what is the philosophy of eigenvalue statistically? That is the between sum of square by within sum of square. Is it okay? So what is our objective? Between sum of square always greater than within sum of square, then groups will be separated. If the between sum of square is greater than within sum of square, then the groups will be separated. And then between sum of square by within sum of square greater than 1. And that's why lambda greater than 1. So this is the main philosophy why we will consider eigenvalue more than. Is it okay or not? So, I hope you understand this. So, next question is very interesting. Next question is, okay, you know, on the basis of eigenvalues, then how many groups can be used? Can you start Jamovi at the same time? Then easily they can understand. Just do it. Are you feeling bored?
No.
Actually, after lunch. Okay. So just you go to factor. Go to factor. Clear? Go to factor. Now, select PCA. Okay? Clear? You select only the independent variable, not census. Because census is the dependent variable. That is the unsupervised learning. You take the only inputs. You take all. Clear? Now, can you select based on eigenvalues? Okay. Thank you. Can you select initial eigenvalue? Okay. How many variables? 9. How many eigenvalues? 9. How many variables? 9. How many eigenvalues? 9. Is it okay or not? So out of 9 eigenvalues, Can you tell me how many values are more than 1? You don't? 2. That means how many groups? Is it okay? Very good. So, these are all 7 variables. The eigenvalue are less than 1. Now the question is, what is the, hello, this is very interesting. What is the meaning of, initially I start with the 3, then convert to 9. Say we get lambda 1 equal to 5.8. Lambda 2 is equal to 2.00. And lambda 3 is equal to 0.1. So automatically question is what is the meaning of it? So total sum is 8. For this problem, there are total 9 lambda and 2 lambda are greater than 1. Is it okay?
Yes, sir.
And what are the summation of lambda? Obviously 9. Why 9? Because we are using correlation matrix. All diagonals are 1. How many ones? 9 ones, sum is 9. Is it okay? So what is the meaning of it? Out of 8, with the help of first factor, that is 5.83 by 8, that is 73% can be explained. Out of 8, because total is 8. Total is 8. How much explained with the first factor? That is 5.83 divided by 8, that is 73% can be explained by the first factor. How much explained by the second factor? 2 by 8, that is 25%. So obviously 2% are left, which is not explained. Because our objective is to dimension reduction. So in this problem, 98% can be explained. Johnson solution. Now connecting with my real life. So with the first factor, we can explain 47.1%. 47. How we get? Eigenvalue divided by 9 into 100. With the second factor, we can explain 25, cumulative 72.6%. So 72.6% we can explain with the two factors. Is it okay or not? So definitely 28% no. Is it okay? Now, so number one is how many groups? How many groups? This is the first question. And these how many groups based on PCA? That PCA with the help of eigenvalue. That is how many eigenvalues are more than one. Some. But the problem number 2 is very difficult. Very difficult. That is, who are the members of the group? This is the second part. Who are the member of the group? Is it clear? So we already discovered there are two groups, group 1 and group 2. So group 2 contains which variable? Group 2 contains which variable? That is the next. Is it okay? So number, how many groups? Try to understand how many groups can be decided by PCA. And PCA, segregated into two parts. One is the magnitude part, one is the vector. So one is the magnitude part. When it is the magnitude part, we take the help of eigenvalue. That is the magnitude. We get some value. And for magnitude part, there is a concept of eigenvector. There is a concept of eigenvector. So eigenvector gives the direction. Direction in which group, which variables we know. So I am giving a very simple example. Now, say x1 is equal to u11 x1 plus u12 x2 plus u13 x. Sorry, this is f1. f2 e21 x1 plus e22 x2 plus e23 x. So no need to compute it because there are two eigenvalue both. Try to understand. So we know the covariance matrix. The covariance. We know this. We know this covariance. Another thing we know, the lambda 1 5.83, lambda 2 2.02. No need to consider lambda because lesser. So we want to calculate, try to understand, these are not known. There is the loading of x1 state. These are not known. How we get it? So to know this loading, u11, u12 and u13, we apply the eigenvalue first. We apply the first element. So how we can get it? So this is u11, u12, this is u13, this is the 3 by 3 matrix, this is the 3 by 1 matrix, is equal to lambda, again u11, u12, calorimeter. So put the value of lambda 5.83. Put the value of lambda 5.83 for the first equation. For the second equation, put the lambda 2. You get this. So if you solve, we get the values of e11, e12, e13. So if you go through the Johnson-Eaton, the problem is solved. The problem is solved. This is the same method. So they are solving like this. U1 equal to 0.384. U12 is equal to minus 0.92. And for the second one, they are solving E23 is equal to 1. E21 equal to 0. E22 equal to 0. I am writing the answer. We shall solve this. But actually, putting lambda equal to 5.83, we can get the value of this. And putting the value of lambda equal to 2, we can get this value this. This is the eigenvector. This is called eigenvector. So eigenvector gives the coefficient of x1, x2, x3. Okay? So that's why it is called the linear combination. Now, try to understand what you get that. And automatically u13 also 0. Now what do you get there? What do you get that? F1 is equal to 3.8384 x1 minus 0.94 is only one. All other zero. So try to understand. From this problem, easily we can say there are the two groups. Group 1, group 2. Group 1 containing x1, x2 and group 2 containing x2. Because there is a connection between factor 2 and x3. There is a connection between these elements. So this is the concept of PCA. Is it okay? This is the concept of PCA. Hello, that's right, no? Hello. Hello. Yes. So now come to this problem. So this is the second kind. Now you go to the cell. Hello, just to check. There are two factors. Old, FPI, foreign, forex. Okay. So what is the advantage of Jamovi? You get one advantage of Jamovi. From these analyses, you can discard some variable. This is the advantage of Jamovi, directly. So what is the rule? What is the meaning of uniqueness? You write, uniqueness means unexplained part. Uniqueness means unexplained part. Clear? So which one is the maximum? FDI is the maximum. Clear? So you can discard FDI from your model. You discard FDI. Because unexplained part is more. So when you discard FDI, then which one is the maximum? You discard CMR. Is it okay or not? Now you try to understand, here all uniqueness value are less than 0.3. There is some literature. If the uniqueness value is less than 0.3, consider the value. If the uniqueness value less than 0.3, consider. Okay, that means unexplained part is less. So out of 9 variables, 2 variables are removed. Is it okay or not? Clear or not? Out of 9 variables, 2 variables are removed. Now again we arrive at a problem. Here dollar, try to understand, dollar in both factor 1 as well as factor 2. It's a real problem. A student good in maths, good in English. So there is an interconnection between two. Simply dollar affecting factor 1 and dollar affecting factor. Is it okay also? So initially for the study, you discard dollar. Initially. Is it okay now? So now we can form the two groups, gold, FPI, foreign and forex. So this is from a group 1. And there is a group 2, oil and Sierra. Group 1 is called gold, FPI, foreign and forex. Is it okay? And dollar affecting both of them. Dollar affecting both of them. More than one variable, দুটো গ্রুপে বেরিয়ে ফেলে same problem, same case করে কোনো সরিয়ে দেবো। Because question is the concept is in case of orthogonal transformation, if you take the correlation between the two group members, that will be the identity matrix. That is the totally groups are separate. That is orthogonal. So initially we try to form the orthogonal. That's why you are separate. Both are similarly separate. Separate. Who will be separate? And not only that, we take this concept, very good question, take this concept, if this loading are more than 0.5. These are the basically correlation value. These are the correlation value. And if this correlation value are more than 0.5. Okay? Up to this okay? So, that means we two groups. So we group G1, we group G2, and we group dollar. Clear? And same sex is the dependent. Now the same sex is a function of group 1, group 2 and dollar. Is it okay or not? So that means group 1 is basically index. Why it is called index? Now it is the composed of 4 variables. That's why it's called index. Composed of 4 variables. Because group 1 contains how many variables? 4 variables. Is it okay or not? Similarly, group 2, again it contains the index. It's composed of 2 variables. So after composing, we get that is called factor score. After composing, we get factor score. So try to understand, originally we started with the 9 variables. So using factorizations, only 2 variables are reduced due to the uniqueness. So there are still 7 variables. And out of 7 variables, we decompose into 2 groups. That is one group containing 4 variables, another group containing 2 variables, and other variable as a separated variable. Why? Because it impacts both the groups. Consider as a separate variable. Because our objective is to form the predictive model. So predictive model means we have to consider the multiple. So now what do we do next? Channel components করতে দেখাবে components summary. The component summary. এটা দেখাবে না তুমি লিখে যাও ডেটাতে যাও না এটা দেখাবো ওটা না এটা হবে ফ্যাক্টর করে আগে চলে ফ্যাক্টর করে প্লট করো ওখানে গিয়ে একটা কোথায় কনফারেন্স কল আছে নিচে আছে আর নিচে যা ও তোর এখানে মডেলটা দেয় তুই ক্লাব জামুবিতে যা go to club জামুবি এখানে you will not get this menu you will not get this menu so for getting this menu we have to open the cloud জামুবি this is the online জামুবি cloud জামুবি
और जाऊंगी
actually কি ফ্রি দিচ্ছে তো একটু কিছু কিছু কেটে দেয় as I said no need to show better you open spaces I am showing the last part using spaces because otherwise time is will be lost same thing you will get in spaces spaces খুলেছিস বেসিস সেন্সরটা খুলে Yeah, sir, you analyze, analyze dimension reduction factor. Sir, 1 minute. You select a bold API. 1 minute, Sharon. Sierra, oil, dollar. Foreign and foreign. Okay, 7 variables. You go to descriptive. You select coefficients. Select determinant. AO. This is the validation part. Extract. 1 minute. You go to the extraction. Select C plot. Click or continue. Rotation. Yeah, this is most important. You select the Varimax. That is the optimal transformation. Varimax. Say continue. Select your scores. 7th variable. Display factor score. Continue. Select options. Sorted by size. And surplus less than 0.05. 0.5 sorry. Now, okay, go. Here, so when you write any paper in factor analysis, you have to explain everything. What is the meaning of determinant? What is the meaning of KMO? What is the meaning of Bartlett's? What is the testing of hypothesis? What is the meaning of p-value? What is the meaning of communal lattice? You have to explain everything. And naturally this is the eigenvalue, 2 eigenvalue more than 1. Okay? Next one. This is the C plot, I will explain. So this is the rotated component matrix you have to explain. Which I explained in Jamobi. 4 in the first group, dollar in second, both the group. Clear? And oil Sierra in the second. Okay, so now, then, after showing the regression analysis, I will go for validation. Now you write sensex is a function of group 1, factor 1, factor 2 and dollar. So that's how you next time you go to the again analyze. Again dimension reduction factor. You discard dollar. Is it okay? Discard dollar. Already I told you dollar. Now you done. Go. Clear? So just to check the 4 in the first group and 2 in the second group. So you go to analyze. You go to regression, go to linear, use syntax as a dependent. Try to understand these two last factor scores. This is the index. This is for 4 variables. This is for 2 variables. And dollar is separated. So as an independent you take this one, then this, then this. Is it okay? And we select statistics. We select collinearity statistics. Here will come. So last part, this is the limitation part. I will show you. That is the you select Darwin Watson. That is the limitation of this paper. Continue. Then click. So what is your R square? What is your R square? 0.764, which are higher than the other methods. In the other methods, we have solved 63, 67, maximum for 74%. And now when you use the regress factor analysis, then it is explained 76%. This is the number one. 1 minute. Number two, your p-values are satisfied. P-values are satisfied. So we can consider this is a model. Not only that, this is a predictive model because VIF is greater than 2. Why is predictive? Because dollar affecting factor 1, also dollar affecting factor. Dollar in both the groups. So this is your model. 76.4%, but you like predicting model. And from this standardized value, from this standardized coefficient, you can take another decision. So that means there are two factors, F1, F2, another value is dollar. So factor 1 will play very significant role for determining the sample. So that is, you can rank the parameters. Rank the parameters on the basis of this value. So if you can go for ranking, so that is very interesting rule. Now how you can rank the parameters? The rule is, when you get these values, you take the absolute value. Absolute value means all are positive. So all are taking the all are positive, that is 7.42, this is 0.285, this is 1.310. Is it okay or no? So out of these three values, obviously this is the most maximum. So this is the rank 1. Ranking of the parameters on the basis of regression. So that is the rank 2. And this is the rank 3. So dollar is the most important to determine cell sex, because dollar affecting both the factors. So I am telling you, the most difficult part for factor analysis is that naming of the factors. Naming of the factors. So when we started my today's class, I started with the 7 subjects, and we divide into 3 groups. One is the physics, chemistry, mathematics. Definitely there is a name that is called basic science. Similarly, Bengali English, forms a group, it has a name language. And similarly, history geography, it has a name class society. So naming is very important. And that definitely naming will be coming from your topic. So naturally it is the finance part. When you do any factor analysis on the marketing job, marketing research, you are naming on basis of your domain. HROB naming on the domain. That is very important. And when you give the naming, proper naming, so you have to relate the naming with the variables. Suppose in case of HROB, motivation is a dimension. So under motivation, what attributes will come, so we have to relate. In HROB, communication. So in the under communication, what attributes will come, you have to relate. Is it okay or not? So in this way, you have to relate the naming. And what are the demerit of this analysis? You go to the above. Now, this is the demerit of this problem. Demerit of this problem is, it is not at all a cross-sectional analysis. So there is a really scope for multivariate time series. Not at all a, cross-sectional time series. Question is why? Here the Darwin-Watson, the value is coming 0.93. So what is that? I am giving a simple example. This is very important. Say, we have written a model y equal to a plus b. This is a model. And for every model, there is some error. Is it okay? Error. So what is yi? Yi is called ith observation. Ith observation. I got it for 1 12. So now we can consider yi minus 1. That is a plus bx plus bx. I minus 1, bi. Okay. So this is the error. So you want to find what is the correlation between the errors. What is the correlation between the errors? So what things you can write like this way. This is summation of I running from 2 to n for an observation divided by summation of ei square I running from 1 to n. So that is called Darwin-Watson. This is the Darwin-Watson. That is the summation of ei minus 1 whole square divided by summation of ei. And if we can break it, so we can simply write 2 into 1 minus first order autocorrelation. That is called autocorrelation. The self-correlation. With a single value. So that is very interesting. When autocorrelation equal to 0, then Darwin-Watson value becomes 2. Just you check. If you put autocorrelation is 0, then Darwin-Watson equal to 2. So when there is no autocorrelation, that is a perfectly equation, perfectly cross-sectional. So now, if the autocorrelation value is minus 1, negative autocorrelation, so then the Darwin-Watson value becomes 4. You put the value. And if your autocorrelation is plus 1, then the Darwin-Watson value is 0. So from this, we can decide that the Darwin-Watson lies between 0 to 4. Because lower limit is 0 and upper limit is 4. So we can make some benchmark threshold value. So what are the threshold values? So we can put 2 here, which is the midpoint of 0 and 2, 4. So we can threshold value is 1.5 and 2.5. Because let us say any analysis based on sample. So we will not get any exact results. So we need some threshold value for cutoff points, cutoff interval. So what is that? That if your Darwin-Watson lies between 0 to 1.5, it is a perfectly time series data. convolution lies between 0 to 1.5, it is a perfectly linear time series data. Okay, and if the convolution value lies between 1.5 to 2.5, so then we can consider cross-sectional data. And if the convolution lies between 1.5 to 4, that is again time series data. So what is the difference between these two? First one is also time series, second one is time series. The difference is that when the Darwin-Watson lies between these, this is called positive auto correlation. Selling price of any electronic goods increasing. So that is called positive auto correlation. And this is called the negative auto correlation. So in my problem, that is the Darwin-Watson value is coming 0.933. Is it okay? So naturally, if we put the value 0.933, easily you can compute the autocorrelation. And you can solve manually, put in the research paper. So obviously, what is the value? Now this is 0.465 nearly 1.01. So rho 1 is nearly 0.535. So high autocorrelation, highly positive. So naturally, this is the limitation of the paper. So in the future scope, we have written in the paper. So there is a lot of scope for multivariate. Because question is why from the domain knowledge, Sensex, depending on time, your all economic, macroeconomic parameters like FDP, CRR, dollar are depending on time. So this is very important. And now I am showing some validation part. I will go to the DC data code. DC data code. You can have PPT Is it clear? Very interesting. Now when so I am asking one question. That question is asked in the interview. What is the difference between this structural regression, which we solve from tomorrow, and simple regression, convenient regression? Because when you start structural regression modeling, that is called structural regression. Conformity factor analysis is structural regression. Everything is regression. So what's the basic difference? Basic difference is, very interesting. This is your conventional regression. So in the conventional regression, there is a concept of dependent variable and independent variable. Is it okay? But in the structural regression, there is some concept we have to consider hiring, try to understand, we have to hiring some extra variable from outside, which is called the latent variable. Is it okay or no? So then this dependent variable, that is the system variable, is called endogenous. And which we hiring from outside, that is called exogenous. So there are two types of variables we are considered in the structural regression modeling. One is the endogenous variable and one is the exogenous. And that's why when you consider this, endogenous and exogenous, this is called the structural regression. So all our path analysis, factor analysis, all is coming under structural regression. Everything. Because when you solve CFA, that is also structural regression. Everything. And when you solve only the regression analysis, that is the concept of dependent variable and independent variable. Now this is the time for tea. Thank you. Sorry. শেষ করে দেবো একবারে? ওরা বলছে একবারে শেষ করে দেবো। তাহলে কি খাবো না? না শেষ করলেই তো বাড়ি চলে যেতে হবে। আমি শেষ করবো না, আমি আগে কি খাবো? কি তাই না? রুল ইজ গুড। এটা বোঝা গেছে? হ্যাঁ? the question. Now your turn. চাটা খেতে হবে কি? ও গাড়ি যেতে হবে।
না আপনি বসুন, আমি বলছি আনতে যে আমাদের ভানু আছে কি?
এবার বসে পড়ুন, আমি চেষ্টা করছি।
আপনি বসুন, আপনারটা আমি বলে দিচ্ছি।
তিন চারটে দিন থাকে না, তাহলে ওই তিন চারটেকে নিয়ে
তোমরা নিচে নামছো তো? যে নামছে সে বলে দাও ওদের দুধ ছাড়া চিনি ছাড়া চা বানাতে। হ্যাঁ, দুটো। হ্যাঁ, আমি তারপরে এটা পাঠাচ্ছি আনার জন্য শঙ্করকে।
হতেই পারে।
এই কে বলে দিচ্ছ? সন্দীপ, এই দুটো দুধ ছাড়া চিনি ছাড়া ওপরে পাঠাবো। দুটো দুধ ছাড়া চিনি ছাড়া ওপরে পাঠাবো। বলছি শঙ্কর একটু নিচে যাও না গো। গৌতম ইয়েকে হয় ভানুটা এখন থাকবে না, হয় দুটো দুধ ছাড়া চিনি ছাড়া গৌতমটা আর সায়ন। হ্যাঁ ওকে বলো, তাহলে ওকে দাও কোনটা
যার সবচেয়ে বেশি ইম্প্যাক্ট আছে
দিচ্ছ? হ্যাঁ ভানু, গৌতমদা ছাড়ানোর জন্য দুটো চা এনে দাও, দুধ ছাড়া চিনি ছাড়া ওপরে। হ্যাঁ ঠিক আছে।
বোঝা যাচ্ছে তো?
হ্যাঁ হ্যাঁ,
হ্যাঁ লাস্টে করতে হবে।
লিকার চা চিনি ছাড়া। লিকার
কবি তো
হ্যাঁ, দুধ ছাড়া।
তাই জন্য
গৌতমদা দুধ ছাড়া তো? ও হ্যাঁ, দুধ ছাড়া চিনি ছাড়া। হ্যাঁ
ওই জন্য তো হচ্ছে মাথা দিতে পারে আপনি অনেক ভালো আপনারা বসে আছেন আমাকে বলতে বেরিয়ে বোঝা গেছে তোমার হবে এবার প্র্যাকটিস করলে আবার ঠিক হয়ে যাবে। কাস্টমাইজ করে হ্যাঁ তখন দেখা যায় এটা কোন জিনিস দিতে যেত শুরু করে প্রবাবিলিটি ছিল ওরা কারা লজিক্যাল করছে তাই না সব জায়গায় কাস্টমাইজ করাতে গেলে ওটাকে আগে টাকা লাগে তাহলে ডিজাইনটা এখন চেক না ওটা কাস্টমাইজ করছে এটা এখন সব রিসার্চ আমরা দেখি না ফ্যাক্টর স্কোর ইন্ডেক্সের একটা কম্পিটিশন আছে ফ্যাক্টর স্কোর ইন্ডেক্স হচ্ছে আমার যত ডেটা সেট আছে ডেটা সেটে নিয়ে রোটেশন আর ম্যাট্রিক্স করে দেওয়া ভ্যালু পেলাম তখন একটা ফ্যাক্টর ইন্ডেক্স তৈরি করবে ইন্ডেক্স ওই ফ্যাক্টর স্কোর তৈরি করে ওটা এসপিএসসি করে জামবিও করে জামবি এই ভাষণে দিচ্ছে না আমরা তো আমার বাড়ির যে ভাষণটা আছে তাদের এই ভাষণে দিচ্ছে এটা এখন হ্যাঁ আছে আমাদের এই ভাষণটা আমার যেটা নিজের ভাষণ সেটা আছে এটা তো সায়েন্সের রিলেটেড ভাষণ ওই করে দিচ্ছে ওটা হুদিন দিচ্ছে ওটা আগে উঠে গেছে কিন্তু ওটাতে এখন একটা স্কোর পাওয়া যায় হ্যাঁ সেটা যে ওইখানে থাকা কোনটাকে নিয়ে নিত ওইটা যেমন দিকে ডাইরেক্ট ওই বসবাস করে এই কোনটা দেয় তাহলে তুমি তেরো আমি তো বুঝতে পেরেছি ওটা ক্লাউড যেমন করে দেয় এখন ক্লাউড যেমন প্রতিটা কমান্ডের যে কি শুনে আমার তো মনে হয় যেখানে যেমন দেখানো উচিত যেমন নিয়ে নেয় তাদের মুখে না আরো ভালো লাস্টে গিয়ে লাভে আমি প্রথমটা দিয়ে যাবো না দিবেন কি করে কাজ করবি এটা আসলে কাজ করবি
আজকে তো মিটিং ছিল বলছি আজকে মিটিংটা ছিল এই ট্রাফিকের মিটিং ছিল
হ্যাঁ ওটা আমি এইচওডি মিটিংয়ে গেছিলাম, ওটা আজকে হচ্ছে না, ওটা কাল হবে। শোনো না, আমি কালকে দিশা যাবো চোখটা দেখা, তুমি কালকে ওটা ঢুকে যাবে।
ঠিক আছে
আমি তো লিখেই ছিল আগের বার, এসব লিখেই ছিল, আর বাকি এমনি কথা হবে, যদি কিছু করে ওটা বলে দিই।
আরে অভিযান করছি তো সবাই যেন নিজের নিজের কম্পিউটার কাজ হয়ে গেলে শাটডাউন করে দেয়, ঠিক আছে? ওটা ফ্রি আছে তো তাই জন্য আমি আরো বলে দিলাম।
আর ইত্যাদি এইটা বলা যাচ্ছে কি সেইখান থেকে সার্টিফিকেট সকালে চলে গেছিল
না আমি সকালে করছি কালকে জিনিস করছি কালকেরটা আমি করেছি আমার মনে আছে আজকেও
আমরা চেক করে যদি থাকে বলে হ্যাঁ আমি সার্টিফিকেট
সন্দীপ, আমি এগুলো গৌতম দ্বারা অনেকটা এগুলো বিলয়কে সন্দীপকে আর সুভাষিসকে আবার ফরওয়ার্ড করে দাও না সিগনেচারগুলো। বুঝেছো, সুভাষিস আর সন্দীপকে।
ফিডব্যাক ফর্ম যাবে, ফিডব্যাক ফর্মটা গেলে ওটাতে সবই মিলে যাবে।
সন্দীপ ওর মেল আইডিটা ঠিক করে দিতে হবে ওর হ্যাঁ করে দিয়েছো তো হ্যাঁ আমার কাছেও আমিও করলাম বলে আমি আরো জিজ্ঞেস করলাম আর সবার গেছে তো কোনো অসুবিধা নেই
Okay, so this is called the schematic diagram of. So initially I have written wrongly. That is not EFA. EFA is a different thing. So I will end the class today using concept of EFA. Really, it is very interesting. So schematic diagram of EFA. So what is the step one? First, you collect the data. Here, collect data on large number of variables. That is G. A large sample N. So N and K must be large. Step 2, input to factor analysis. You find correlation matrix or covariance matrix. Then model and extraction method. So what is the extraction method? PCA. And PCA you get the number of factors say R. R means reduced. Initially K variables, now it is reduced to R. এখানে একটা জিনিস লেখা হয়েছে R less than K. R less than K. So determine the number of factors for rotation R less than K. Is it clear? Definitely R less than K. Now we apply rotation matrix. So there are two types of rotation matrix. One is the orthogonal and the oblique transformation. And rotate selected factors. So this is basically, used in SEM. This is basically used in SEM, step 6. This is used in structural equation modeling. And these are the factor analysis jargon. So many jargons are used in factor analysis. Number one jargon is you have to know what is correlation matrix and what is correlation. It's a jargon. Second thing, you have to know the concept of extraction. We are using the Varimax, orthogonal extraction. If we use the Promax, that is the oblique extraction. So we have to know this. We have to know this the commonality, which is very, very important, commonality. That is how much we can explain a variable with the factors. Basically, for the remember, this is nothing but R square. Commonalities is nothing but R square. So, again rotation. Then, these the pattern and structure matrix. But these are all for structural issue. Stopping rule. When you stop, that means your problem is not okay. First of all, value of the determinant. That is the stopping rule. On the basis of determinant value, we can take the decision our factor analysis is relevant or not. Very important. Next, KO values. KO value, that is the concept of sample correlation and partial correlation. That is the measure of sample adequacy. Your sample size is enough or not. That you can take the decision for KO values. So there is some thumb rule. If KO is less than 0.5, immediately stop. So after immediately stopping, you try to modify your sample or modify your inputs. So KO is very important. And naturally most of the researchers, literatures, if your KO is more than 0.7, so now is the Bartlett test of sphericity. This is basically, the testing of hypothesis. Testing of hypothesis. So I am showing you lastly very interesting part. Okay, why mathematics is important. Say, if I say 1, 0, 0, 0, 1, 0, 0, 0, 1. Can you tell me what is this? This is called identity matrix. Now, what is the importance of identity matrix in factor analysis? Identity matrix means x1, x2, x3, x1, x2, x3. So these three are no relationship. Because x1, x2, 0, x1, x3, 0. So no covariance, no correlation. So identity matrix means that's the linearly independent. Linearly independent, that is the identity matrix. So naturally, when you can take this identity matrix, what is the value of the determinant 1? And when the value of the determinant is 1 coming, so that means they are the linearly independent, no multicollinearity of. Okay. But if I take this matrix, 1, 0.9, 0.9176 matrix, so what is the value of the determinant? 1.0.821, that is 0.19. So it is tends to 0. So when some value of the determinant tends to 0, that is the high multicollinearity of. So that's why the value of the determinant will play a very, very important role for the factor. Is it okay or not? So what is the hypothesis? I am telling you what is the hypothesis. Hypothesis is like this for factor analysis. Since it is the multivariate, so that is called capital C. Capital sigma is, you know, the multivariate covariance matrix or multivariate population. And that is equal to capital I. What is I? Identity matrix. Identity matrix. What is H1? Sigma not equal to 1. That means if your H0 is rejected, only we can run factor analysis. Because if your H0 is accepted, that means it is identity matrix. Identity matrix means there is no multipolarity factor analysis. So that is the main concept of hypothesis. And everywhere, every factor analysis, p value always less than 0.0. Okay, this is very important. Next part. Commonalities. I am telling you, but if you ask me, what is the main important part in factor analysis? Then I'll say ranking wise, commonality is the first. Question is why? Because using commonalities, we can discard variables. So if you ask me, what is the importance of so many things? What is the importance of this out of it? First rank is the question is why? So that affects. Now I am giving the concept of EFA, then you can understand why the commonality is important. So most of the researchers, they are using factor analysis, don't mind. I am also doing that. But recently my age is increasing. So naturally I am thinking I have to do some perfect work. But still, that's why nowadays when I am solving the factor analysis, I am using EFA. Question is why? Because in case of PCA, there are some limits. And but in case of EFA, that we can reduce that. But what is EFA? That is very interesting. What is the difference between PCA and EFA? Say I have 4 videos.
Sir, you are inaudible from here.
Oh, audible now? Sorry. I have extended.
Yeah.
This is the part, given it of Sion. And a battery, no battery. Hello. Battery. Sir, if you don't mind, please. copy easily can solve here. Say now is okay. Now say there are 4 variables. Clear? In case of PCA, what you are doing? You are doing 1, R12, dot dot dot, R21, dot dot dot, in 4 by 4 matrix. Correlation matrix. Then what do you do that? You find the eigenvalues. And you get the values of lambda 1, lambda 2 and so on. Then the eigenvalues which are more than 1, that is the number of atoms. Already I have told. Now what is the concept of DFA? Most of the researchers, they are telling that there are so many limitations of this. What is the limitation? Limitation is we are taking diagonal values are 1. But we are considering factor analysis for the multiple variable. So what they are doing? They are considering x1 as a function of x2, x3, x4. Already I discussed in case of BIF. And solving this equation, we get R1 square. This is called squared multiple correlation. R1 square means squared multiple correlation. So in the matrix, we put R1 square, R12 and so on. Similarly, in the second step, R21, R2 square, that is how much x2 can be explained by the other variables. Similarly, in the R31, R32, R3 square and so on. And we construct again 4 by 4 matrix. So we create a 4 by 4 squared multiple correlation matrix. Is it in the diagram? So what is the advantage? Advantage is these R1 square always less than 1. Because R1 square lies between 0 to 1. Now we apply the concept of eigenvalue, this matrix. Here it is 1 minus lambda. And here it is R1 square minus lambda, R2 square minus lambda. So automatically the eigenvalues are changed. So researchers are telling you solve the eigenvalue using PCA and you solve the eigenvalues using EFA, and if there is no difference, moral your factor is the full factor. So EFA is the more accurate. That's why it is called principal axis factor. And I am telling you one thing, if your EFA is satisfied, so you will be lucky enough, your CFA will be satisfied. Again repeat, if EFA is satisfied, you are satisfied with the EFA, your CFA will be satisfied. Okay. So lastly, so commonalities also used for dimension reduction. So if you check, in case of commonality, some value is less than 0.5, in commonalities you can easily discard them. Easily you can discard them, even that the variable having no importance. So commonality also used for dimension reduction. Okay. Next diagram. And naturally there is another diagram, eigenvalue, eigenvector. Already I told you. Then component matrix, and the last one, in the interview board, so many places a question will be asked. So what is the validation technique of factor analysis? What is the validation technique of factor analysis graphically? The answer is creep plot. So why it is creep plot? Because creep plot basically is called elbow rule. Elbow rule. So this is our elbow. So in case of elbow, if we take, if this is the x-axis and this is the y-axis, an angle between this is the 90 degree. Suppose So very interesting. So we consider. You consider this is x-axis and this is y-axis. Clear? And if we have say 7 variables x1, x2, xn. Okay. And this is the eigenvalue. Eigenvalue. So you get 7 eigenvalues. And out of these, so some eigenvalues is lies between 3 to 4, some is 2 to 3, and some is, and all values are less than 1. And you join this. Join this. Script log. Join this. So just you check these two eigenvalues are more than 1. Okay, that means 2 groups. And this is the remaining eigenvalues which are less than 1. And joining this by a straight line. And if we join this line by a line, looks like a parallel to x-axis. Looks like a parallel to x-axis. If you check that, this is the parallel to x-axis, it is a perfect vector. But in most of the cases, you will not get this. Another concept is how we estimate your factor is good enough. If it is explained more than 90%. More than 90%. That is the good factor. Okay? So these are lot of factors. Naming of the factors, already I told you. And this is the mathematical jargon, how we get the index. Already Sulagna ma'am asked the question. So this is the how we calculate the factor score, that is the factor index. And concept of regression to understand how we do it. Concept of regression to understand the probabilities. Okay, so next. And these are the basically formula for chi-square, Bartlett test of chi-square. This is the basic formula, theoretical thing. And after getting the formula, then definitely go for case study based on secondary data or based on. And lastly, finally, I am telling you, don't mind, most of the cases we are solving structural equation modeling for secondary data, but to some extent it is wrong. We apply structural equation modeling basically for primary data. Basically. Because if it is primary data, so then there is a question how to validate your data set, how to validate your scale. So to validate scale, really you need the structural equation modeling. So mainly we apply, because when you start structural equation modeling, so there is a term, so we have to group the predefined groups. Already groups are predefined, and that we have to validate. Our predefined groups we are taking correctly or not. So that's why mainly we are applying factor analysis for the primary data research. Because primary data you put the groups and then you validate. Okay, any question? And this is the 5-5. Lastly, I will show you the last part. Madam asked me, you go to Jammu. Last part. Madam told me, just one line, how can I show the same in Jammu? N minus? Very good. The concept is very good question. We know x plus, is it visible? Y plus z equal to 6, suppose. X plus y plus z equal to 6. Can you take x plus y plus z equal to 6? First question is, can you solve these three unknowns? X plus y plus z equal to 6? The answer is no. But another answer is yes.
Two values given.
Yes. So from this equation, we can write z is a 6 minus x minus 1. And from this equation, we can write z equal to function of xy. So what is the meaning? Z depending on xy. So that means, if we take x equal to 5 and y equal to 1, then z equal to 0. Am I not right? If we take x equal to 2 and y equal to 3, then z equal to 1. That means we are taking the several values of x and y and z are coming, because z depending on x and y. So we can consider x and y are independent. Z is the dependent. So in this equation, how many independent parameters? 2. Now what is the degrees of freedom? 3 minus 1, 2. Now come to the point standard deviation. Standard deviation, yes, that is equal to 1 by n. I don't know. That is equal to summation xi minus x bar whole square. And we divide y it is n minus 1. That is your question. So naturally, for standard deviation, we have to depending on x bar. So without knowing x bar, how could I calculate standard deviation? So definitely we have to depend on x bar. So how many parameters we are losing? 1 parameter we are losing. So instead of n, it is n minus 1. And that's why it is called the unbiased estimate. So in case of standard deviation, we do. Not only that, in case of covariance also, we divide 1 by n minus 1. Okay. So that is the concept of degrees of freedom. I am telling you, when you start with the structural equation modeling, so degrees of freedom will play very, very important. Very important. And that is the concept of, the hypothetical model is saturated. If we degrees of freedom are losing, tends to the saturation. Simple. Degrees of freedom is very, very important. Then when you solve details, degrees of freedom, chi-square, degrees of freedom, A, degrees of freedom. So, madam, you like to check still now? Okay, Sharon, open Jamu. Jamu, please open. You go to the factor analysis. Go to the factor analysis. You go to the CFA part. So, madam, I am solving. So that is you select factor 1, Sharon, you put the values. Gold, yeah. Then you have to know definitely. Already solved. Then Sharon is variable. 1 minute. API. Then foreign. Then forex.